This is the screencast for section 6.2, example 2. We're going to use the dot product to find length or magnitude. Now in the screencast for example 1, I said that property 2, we were going to explore that a little bit more. So let's start out with property 2, and we're going to use the dot product to find the length of the vector u by using property 2. Now property 2 says that the magnitude of vector u squared equals the dot product of u to itself, which sounds strange, but let's just go with it. So I'm going to take the square root of both sides, and therefore the magnitude of our vector u, which is 4, -3, is going to equal the square root of the dot product of that vector and itself. So under the square root, I would take the product of the x coordinates and add the product of the y coordinates, which in fact is the square root of 4 squared plus -3 squared, which is by definition just the magnitude of a vector. So that's where actually property 2 comes from. It goes backwards from the magnitude to discover that the magnitude of a vector squared is actually the dot product of its vector. So in this case, I know we just had to find the length of the vector, but it said specifically to use the dot product to find the length. So instead of just finding the magnitude, we had to go the dot product way and remember what property 2 was. So this is going to be 5. The now try problem number 9 also says to use the dot product to find the magnitude of u, or the length of u. Well, now I know that the magnitude of u is the square root of the dot product of itself. So the magnitude of 5, -12 is going to be the square root of the dot product of 5, -12 and itself 5, -12. So I get that the magnitude of u is 13, but I use the dot product to find it.